Today we're going to look at the second method for finding the vertex, and that's called by completing the square. Now, if you're given an equation in standard form, okay, so no brackets, and we want to turn it into vertex form, we do something called completing the square. And all of the steps are written out for you, and we're going to go through a few examples together, and then I'm going to have you try a few on your own. But pretty much the basis of completing the square is trying to create a perfect square trinomial in your quadratic to factor later on. Okay, so my first step is to common factor the coefficient of the x squared term from the first two terms only. Okay, so common factor from the first two terms. So if I have y equals 2x squared plus 4x minus 3, I'm going to look at the 2x squared and the positive 4x, and I notice my common factor is going to be the 2, that's the a value. Whatever a is, you're factoring it out. I don't care if you get a fraction. When you do that, you have to factor out the a value. And do not factor out the x. That's important. So now, y equals 2. Keep that common factor in front. And then I'm left with x squared. And then 4 divided by 2 is 2. So I have 2x. I close my bracket, and I keep my minus 3. Okay, so I'm going to highlight this. Do not factor out the x. Okay, now, what we're going to do right now, we are going to try to find a number that we can add and subtract to this bracket to create a perfect square trinomial. So to find this magic number, we divide the coefficient of x by 2, and then we square it. So this value right here, I'm going to do 2 divided by 2 squared. So 2 divided by 2 is 1, and when I raise it to the power of 2, I get 1. And now, so that's how you find your magic number. Divide by 2 squared. That's important. Okay, now you're going to add and subtract that value to inside your bracket. You have to add and subtract because if I'm doing positive 1 minus 1, then that really simplifies to 0. So I haven't actually changed anything. That's why I need both operations. So I'm going to have 2x squared plus 2x plus 1 minus 1. Close that bracket. And we can't forget about the minus 3 at the end. So I technically haven't changed anything, because if I were to collect my like terms, it would simplify to the same thing. Okay, now we want to move the last term in the bracket outside. And the way we do that is by multiplying it by that a value. And that will just take it out of the bracket. And the reason we do that is because we want to be left with a trinomial so that we can factor it later on. Okay, so we're moving the last term. So now I have y equals 2x squared plus 2x plus 1. Close my bracket. And then 2 times negative 1 is negative 2. And we can't forget about that minus 3. Now, if you look inside your bracket, we have a perfect square trinomial. Because x squared is a perfect square, 1 is a perfect square. The square root of x squared is x. The square root of 1 is 1. And when I multiply them and double it, I get 2x, which is the middle term. So that whole process of finding the magic number up here is how we ensure we get a perfect square trinomial. That way it's not a guess and check process. Okay, it's pretty much what we do here by dividing by the 2 and then squaring it is the opposite of 2ab, pretty much. So now I can factor the perfect square trinomial. So I have y equals 2. The square root of x squared is x. The square root of 1 is 1. I'm going to put addition because my middle term is addition. I can't forget about that exponent of 2. Okay, and while I'm doing that, I'm also going to collect my like terms. Negative 2 minus 3 is negative 5. Now it's in vertex form. And what is my vertex? Well, here's h. Here's k. I can't forget opposite sign inside the bracket. So negative 1, negative 5. And there it is. Okay, it seems like a lot of steps, but once you do a lot of practice, you get in the habit and you get a lot quicker at it. So let's try example 2 together. So for the first two terms, I'm going to factor out whatever a is. And a happens to be negative. So I factor out that negative 5. and my first term inside the bracket is always going to be x squared. And then 20 divided by negative 5 is negative 4x, so be careful with your signs. Okay, now I want my magic number, so I'm taking this negative 4, I'm going to divide it by 2, and then I'm going to square it. Negative 4 divided by 2 is negative 2, and when I square it, I get 4. So this is the magic number I'm going to add and subtract to my bracket. So y equals negative 5 x squared minus 4x plus 4 minus 4, and then minus 16 on the outside because I don't care about that right now. Okay, now I want to get rid of that last term because it's not part of the perfect square trinomial, so I distribute the negative 5 in. So I keep negative 5 on the outside, I keep that perfect squared trinomial inside my bracket, and then negative 5 times negative 4 is positive 20. In this step, you can also factor the perfect square trinomial right away, but this is just us taking baby steps. Okay, and again, I have that perfect square trinomial. The outsides are perfect squared, and the fact that I did that magic number operation, I know it's a perfect squared. I don't have to check it. So now when I factor it, I have negative 5. The square root of x squared is x. The square root of 4 is 2. I put minus because the middle term is subtraction. And I square it and collect my like terms. 20 minus 16 is positive 4, which makes my vertex positive 2, positive 4. Now I want you to notice something. When you're finding the magic number, the number you get when you divide by 2, so this 1, this negative 2, that actually ends up being the number in your bracket for your perfect square trinomial. So you can always look there, or you can take the square root and look at the sign. You have different options here. Okay, so to recap, common factor, the coefficient of a from the first two terms, find the magic number using your b, so divide by 2 and square it, add and subtract that value, distribute to get rid of the subtraction value, do the perfect square trinomial, and you're done. Okay, so I want you to try number 3 on your own. The steps are written out for you. Follow what we've been doing. Okay, notice the a value is negative 3, so make sure you factor that out for your first step. Okay, once you do it, come back to the video and see if you did it correctly before you move on to number 4. Okay, so this is what you should have. Some common mistakes. Make sure you factor the negative 3 out, not just the 3, which means the middle term will now be positive 4x. Your magic number should have been 4, so hopefully if you did that math and you did it properly, you add and subtract 4 to your brackets. Okay, another common mistake, make sure when you distribute the negative 3 into that subtraction term, so into the negative 4, it becomes positive 12. And the perfect square trinomial would be x plus 2 squared. And your final vertex, negative 2, comma 13. Okay, so if you made any mistakes, highlight the step you made a mistake on, okay, so that you can practice that and be really careful. Okay, number 4 is a little different because our coefficient is 1. Okay, so I'm just going to start it off. Right over here, my common factor is technically 1. If you want to write it as 1, cool. If you just want to put brackets around the first term, that's fine as well. It's really your choice. So you can write it as x squared minus 6x and then plus 5 in the brackets. Or if you want to put the 1 in front, you can do that as well. But that imaginary one doesn't really mean anything to me, so I don't write it. Okay, and then from here, do the rest of the steps. So pause the video and then come back when you finish. And if you made any mistakes in number 3, try to correct them for number 4. Okay, so your magic number, when you divide by 2 and squared it, should have been 9, so that's what I'm adding and subtracting. I put that imaginary invisible 1 for my coefficient just to show that when I distributed into that negative 9 at the end, it doesn't affect anything. So technically you could have just taken it out of the bracket if you wanted to. When I factored the perfect square trinomial, it gave me x minus 3 squared. When I collected my like terms, I got negative 4 over here, so that my vertex was 3, negative 4. Okay, I want you to try number 5 on your own, which is y equals 3x squared minus 6x. There isn't a constant at the end. If you want to put a plus 0 so it looks more familiar, you can, but you don't have to. Treat it the same way. Factor out that 3 from the first two terms, or only terms in this case, and then continue from there. Okay, so for number 5, I did all the same steps as before. Okay, factored out the 3, found my magic number, which was 1, added it and subtracted it, and the only difference is when I distribute that 3 in to take out the negative 1, all I'm left with is negative 3, so there's nothing to collect later on. Okay, so your vertex should have been 1, negative 3. Now I am going to do number 6 with you because we do end up with a fraction when we find our magic number, and I just want to show you how to deal with it by not turning it into a decimal. Okay, so our first step, just like before, common factor out, in this case, the 2. So that I'm left with y equals 2 bracket x squared plus 3x, and then the minus 1 at the end. Now, notice that middle term is odd. So when I do 3 divided by 2, I can't simplify that, or I can, but it's a decimal, and I don't want a decimal. And then I square it. So if I can't simplify when I divide by 2, I'm just going to apply the exponent to both the top and bottom. So 3 squared is 9, 2 squared is 4. So my magic number, unfortunately, is going to be 9 over 4, and that's okay. So now, I go y equals 2 bracket x squared plus 3x, add 9 over 4, subtract 9 over 4, close your bracket, and don't forget about the minus 1. Now, I'm going to bring the 2 in, so I'm going to multiply it by 9 over 4, and if you want to put it over 1, you can. Y equals 2 x squared plus 3x plus 9 over 4. Okay, and then you're going to have 2 times 9 is 18, 1 times 4 is 4, so it's going to be minus 18 over 4, but 18 over 4 simplifies to 9 over 2. And actually, while I'm doing that, because I know I'm going to have to collect like terms with the minus 1, I'm going to put minus 1, which at this point is negative 1 over 1, as negative 2 over 2 for later on. So I got that common denominator for the negative 1. Then I also simplified my fraction to make life easier. I did it in a few steps just because I don't have space. You could have done little side steps for yourself. Okay, and now we can factor that perfect square trinomial that's left inside the brackets. The square root of x squared is x. I'm going to have addition because of the middle term. And then the square root of 9 over 4. Well, the square root of 9 is 3. The square root of 4 is 2. And then I raise it to the power of 2. Notice that this 3 over 2 is the same thing that we got in the bracket before we squared our term. Okay, and now when I collect my like terms, I have negative 9 over 2 minus 2 over 2. So my denominator stays at 2, and the numerator becomes negative 9 minus 2, which is negative 11. So our vertex is negative 3 over 2, comma, negative 11 over 2. So really, fractions don't do that much. You just have to remember how to multiply by that coefficient. So multiply the numerators, multiply the denominators, and make sure you remember how to get a common denominator to subtract or add later on. And that's it for completing the square. Hopefully it seems a little less overwhelming now that we've done 6 examples. But again, there are a lot of steps, and it's just something you have to memorize. There is logic to it, though. Okay, the whole purpose of completing the square is to get that perfect square trinomial in your bracket, so we get this bracket squared at some point. Okay, and because the a value is factored out, that's why we factor it out at the beginning, because of what vertex form looks at the end. And then we find the magic number to introduce the perfect square trinomial so we can get the bracket squared. And then the leftover is just the coefficient that we collect like terms later on for, to get that k value. So there is logic to it, but the more practice you do, the faster you'll get at it, and the easier it will seem. Okay, so make sure you're doing practice.